Welcome back, Geometry section, Chapter 8, Section 4. We're talking about angles of elevation and depression. And so warm it up, come back and check your work. And you identified the pairs of alternate interior angles, 2 and 7, angle 3 and 6. You found the tangent of 30 degrees to the nearest hundredth, 58 hundredths. And you solved for the missing number in this ratio, and you found a big number, 1,816 and 36 hundredths. So today, the objective is to solve problems involving angles of elevation and angles of depression. These are converse terms, aren't they? Elevation and depression. So we have those terms in our vocabulary today. So the angle that is formed by a horizontal line and a line of sight to a point above the line, like angle 1 here, is an angle of elevation. It is the angle of elevation in this figure from the tower T to the plane P. So angles of elevation are formed from a horizontal line above that line to a point, somewhere up there. What is the angle that's formed? And the angle of depression is an angle formed by a horizontal line and a line of sight to a point below the line. So angle 2 here is an angle of depression from the plane to the tower. So what's cool about this is that since the horizontal lines are parallel, angle 1 and angle 2 are congruent by the alternate interior angles theorem. The angle of elevation from one point is congruent to the angle of depression from the other point. Very cool and very nice graphic, don't you think? Okay, we're going to classify angles of elevation and depression. Classify each angle as an angle of elevation or an angle of depression. And don't get in too big a hurry. Angle 1. Angle 1 is an angle of depression, right? It's the angle formed by the horizontal to the top of the tree, hitting down to the point where this person stands. Angle 4 in here, well, how would you classify that? This angle is formed as an angle of, that's right, elevation, right? From the horizontal line, which looks at ground level, to a side above that line. Good. The Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? We're rounding to the nearest meter. This is appropriate since Seattle just won the Super Bowl yesterday. So the first thing we might do is draw a picture, right? So we have a Space Needle, we have a shadow, and we have an angle of elevation. And the Space Needle and its shadow form what type of angle? You got it, a 90-degree angle. So the question is, how tall is the Space Needle? So we're looking for y here. And what might we use to find it? And you got it, one of our trigonometric ratios. So if we look at angle 70, the unknown side is opposite, right? Opposite over a known adjacent. Opposite over adjacent is what ratio? Good, that's the tangent. And so we can use our inverse ratio, right? So first we sketch, and then we say the tangent of 70 degrees is the unknown over 67 meters, and we simply solve. So our unknown value is 184 meters rounded to the closest meter. Suppose there's a plane at an altitude of 3,500 feet above ground, right? Above sea level. And the angle of elevation from the airport to the plane is 29 degrees. So we'll say the 3,500 feet is above the airport, the elevation above the airport, right? The angle of elevation from the airport to the plane is 29 degrees. So what is the horizontal distance between the plane and the airport? Round to the nearest foot. So again, you could draw a triangle, right? You can draw a point up in the sky, right? It is 3,500 feet vertically from the base of a triangle, forming a right angle, right? And a 29-degree angle of elevation from angle A, okay? And so we're now looking for the horizontal distance between the plane and the airport. Here's the airport, there's a plane, A and P. And so we're looking for what feels like a base of this triangle, right? And so what relationship, again, what trigonometric ratio is formed using sides that are opposite over adjacent from a given angle? That's right, our tangent ratio. So tangent of 29 must equal 3,500 over the unknown horizontal distance. And so we can solve this. And we find that the horizontal distance is 6,314 feet. So we're just spending today really looking for these triangles, aren't we? And using our trigonometric ratios to find either heights or horizontal distances primarily, right? An ice climber stands at the edge of a crevice that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is the crevasse at this point? Round to the nearest foot. Okay, so begin by drawing your triangle that represents this. We have an ice climber. We have a 115-foot wide horizontal distance, right? And we're looking for a vertical distance. The climber forms a 52-degree angle with the bottom of the opposite side. So there we go. And we're looking for the depth. Okay, so this is interesting. We have this 52-degree angle here, which is not interior to this triangle, is it? So what might we do? And by the alternate interior angles, let's look back, alternate interior angles here, we know that angle B is 52 degrees, right? Angle B. Okay, so we are looking for then the opposite over adjacent, the opposite side from this 52-degree angle. Again, the tangent ratio, right? So tangent of 52 is y over 15, and we simply multiply 115 times tangent 52, and we have a depth of 147 feet. Suppose the ranger sees another fire, a fire. Okay, this is a takeoff from an example in the book. But suppose that there's a ranger in a tower, fire tower. They have these all over the Rockies, West Coast. They're in a lookout, spotting fires and then calling for help if they see them. So suppose a ranger sees a fire, and the angle of depression to the fire is 3 degrees. Here it is up here, 3 degrees. So what is the horizontal distance to this fire? Round to the nearest foot. Once again, that angle of depression is exterior to this triangle, but it is an alternate interior angle to angle F here. So we can say that this is a 3-degree angle. We know the height of the tower is 90 feet. And we're looking for the horizontal distance. Okay, pause, come back and check your work. Once again, we have a tangent ratio, opposite, which is known, 90 feet over x, right, equals the tangent of 3 degrees. And when we solve for x, we have 1,717 feet. Here's one for our coastline here. An observer in a lighthouse is 69 feet above the water. He sights 2 boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. The angle of depression to the other boat is 22 degrees. So what is the distance between the 2 boats? Very fun. So we might find, to begin with, the distance from the observer to the nearest boat, and then we'll find the distance from the observer to the other boat, right? And then let's look at the difference between those distances. Okay, so so we can draw a sketch. And there you go. We have the man in the lighthouse. We have the angle of depression to the nearest boat, A. We have the angle of depression to the further away boat, B. And so we have two right triangles, don't we? Keep in mind the lighthouse is 69 feet tall. So that's the same for both, right? And now we simply find these horizontal distances. We want to find, easy to find y and z, and then we find the difference and we'll find x, the distance between the boats. So to find y, again, find y, we have which angle? 48 degree, right? Opposite over adjacent, we're finding the adjacent side, y. And so go ahead and pause, make sure you're working this out carefully. The distance is 62 1/10 of a foot. Secondly, we can find z. I'm looking at the picture again. We're finding the whole distance, the horizontal distance from the observer to the second boat, using that 22 degree angle this time, right? And so when we do, again, we have 170.8 feet. So the distance between the two boats will be the difference between their horizontal distances from this lighthouse observer, right? And you should have found 109 feet apart. Very cool application of this method, right? Go ahead and pause. Check your answers when you are ready. Angle of depression is angle 6, and angle 9 is an angle of elevation. Please pause, try these, and come back and check your work. For number 3, we have 54,115 feet. And for number 4, we have 12 feet. Very good. Have a great day.